Good morning. We are going to learn about inverting adder circuit. So we have the two types of adders using op amp. First one is inverting adder and non-inverting adder. We gave the input to the inverting terminal so that it is going to add the inputs from the inverting terminal only. So that's why we call it as an inverting adder. So my input signals are V1 and V2. This is V1 and V2 are my input signals. So that it is going to produce the output as a V1 plus V2. So I'm assuming this one as a node A, voltage at node A, VA, and also non-inverting terminal is grounded. So voltage at the non-inverting terminal is equals to 0. So according to the virtual ground concept, if the one of its input terminal is grounded, then automatically other input terminal node voltage will become 0. So that I am writing the VA as a 0 here. Now current flowing through I1 through the resistor R1 due to the V1. So the current flowing through the resistor R2 due to the voltage applied at the V2, that I am assuming it as an R2. So current flowing through the feedback resistor due to the application of the voltage. So I am writing it as an IF. The current flowing through the feedback resistor is IF. Now I am going to apply the KCL to this circuit, Kirchhoff current law. So total current entering into the node VA is equals to I1 plus I2, and the total currents leaving from this node is equals to IF. So now I am writing the equation for this circuit. So I1 plus I2 is equals to I1 plus I2 is equals to IF. Now I am writing the equation for I1. I1 is equals to V1, that is applied voltage V1 minus VA by resistance is RF. I is equals to V by R. That's why I'm writing it as V1 minus VA by RF. V1 minus VA by RF. Sorry, RF. It is not RF, R1. The resistance which is here is R1. Now I2 value can be written as I2 current is here. So V2 minus VA by R2. V2 minus VA by R2, that equals to IF. What is IF? IF is equals to VA minus V0 by RF. VA minus V0 by RF. So as we know that that VA value is 0 because these two are virtually grounded. VA value is 0. Now I am substituting the value of VA 0 here. Here also 0 and here also 0. So this equation can be rewritten as V1 by R1 plus V2 by R2 equals to minus V0 by RF. So we need to write the output voltage expression, so that output voltage expression V0 is equals to, from this equation, V0 equals to minus RF into V1 by R1 plus V2 by R2. R2 into, that's it, V2 by R2. So this is the output voltage expression for inverting adder circuit. Now from this equation I am going to write the voltage gain expression. Voltage gain expression means V0 by Vin. V0 by Vin. We need to write the equation for V0 by Vin. So here if you assume V1 equals to V2, then V0 by Vin is equals to RF by R1 plus RF by R2. Okay, right. So let us assume I am going to make one assumption that that equals to R1 equals to R2. I'm going to make one assumption, R1 is equals to R2 equals to R. R1 equals to R2 or R1 equals to R2 equals to R. then we can write this expression as V naught is equals to minus RF by R into V1 plus V2. Okay, this is a voltage expression, output voltage expression for this particular inverting adder circuit. Suppose if you want to write the output voltage expression, if RF is equals to R, then these two are equal. If these two are equal, then we are going to write the output voltage expression RF is equals to R, then output voltage expression V naught is equals to V1 plus V2. Sorry, this is V1 plus V2. This is the output voltage expression for inverting adder circuit.